Hello everyone, and thanks for taking a few minutes to take a look at this quick product video. Ever since the release of USB 3.1, I've been kind of intrigued to try, to look for peripherals that would actually take advantage of the interface. So far the challenge has been to find actual items that are available. I did run across this Silverstone TS231U-C, which is theoretically a Gen 2 Type-C USB 3.1. So I kind of want to walk you through all the basic features. It's a very simple device, and then we can run a quick benchmark so you can kind of get a feel for how well it works. Okay, as you can see here, there's not a lot to the device. You can see there it's actually a cageless type device where you can actually slide the drives in and out. So it's relatively simple to plug together. There's only a power switch in the front, and I'll show you the back interfaces here in just a second. Okay, so if you take a look at the back interface here, the back of the device here, you'll see the hardware RAID configurations can be configured through the dip switch, and there's very little else on there. There's a set button, which once you configure the switches, you can basically press and hold the button for 5 seconds and it actually configures the device. There's no software, no anything to run. And then obviously the right is the power plug, and then on the top is a 70mm fan, which I guess if I had to rate the whole thing as a weakness, that would be it, because the fan isn't the quietest thing I've ever heard. If I end up keeping this device, I'm going to have to probably do a fan mod and just either replace the fan or use a resistor to actually slow it down a little bit, because it is kind of noisy. It's a lot noisier than I like for a desktop device. My PC is virtually inaudible, and when I stick this on the desk, it just sounds terrible. So it is an issue and something I need to fix if I choose to keep this. So let's take a look a little bit closer and see how this thing works. So again, just a little close-up on the actual switch configuration. Let's get into the configuration a little bit. As you can see, it installs itself as a hard drive. You can see it under where it says Data Scratch, the M drive. But basically, I had a really difficult time getting this device to actually detect through the USB interface. I actually had to go into the motherboard BIOS and configure that particular USB device to be a hard drive under the USB controls of my motherboard, which is not something that should really have to happen. So I'm hoping it's just something that they can fix later in the firmware. So let's get into a little bit about the benchmarking and how it works. So again, to set the stage, I've put in two Seagate 3TB drives which are 7200 RPMs. They're reasonably fast drives. I put these into a mirror configuration. So as you can see here, I've got the benchmark ready to go. I put the captures of both the C and the D drive for comparison, and these are obviously SSDs. One is an M2 NVMe drive, and the other one is a regular Samsung Pro 850 Pro. So here we're going to take a look at the benchmark that runs as a USB drive using the USB 3.1 interface, again with two 3TB drives in a mirror configuration. So the limitation of the interface will strictly be the drives. Okay, so let's go ahead and run the benchmark. I'm not going to have you sit through the whole thing, so I'm going to show you the beginning and the end just to kind of keep it in perspective. So let's go ahead and start. So let it run here for a few minutes. You'll see by the end of the test run that the bandwidth is actually very good. There's no inherent bottlenecks from the interface, at least it doesn't appear to be, but we're obviously extremely limited by the drive performance itself, even in a RAID configuration. Okay, so the test is about to finish up, and as you can see from the curve, there's a nice sharp performance curve. It's definitely being tapped out by the drives themselves. But as you can see, overall, given the fact that the two C gates themselves in a RAID configuration are getting some slight benefits from the RAID controller, the performance is actually pretty good. So for a scratch disk, or for your, as a data drive or as a backup drive even, you can certainly tap out the maximum capabilities of your drives. It's not super easy to put an SSD in these, otherwise I would probably try that as well. But stay tuned for the next device I've got coming, because I've got something on order that will hopefully take a little bit more advantage of the SSD configuration and see if the interface itself can be pushed. Now, again, in closing, I wanted to mention that my experience with this, and I haven't really traced it down to one of the three variables, it either doesn't like, at least consistently doesn't like to be detected, and it will periodically drop out. I can't really detect to see if it's actually the cable, because I am using an extra long cable, and for USB 3.1 Gen 2 that's not a good plan. Most of the cables you see available today are in the 3-foot range. This happens to be a 6-foot USB cable, kind of a cheap one, so there's a lot of variables there. There's obviously BIOS, the relatively new BIOS that's in this motherboard, so there's a lot of variables there. And then there's the device itself, which I suspect most of the flakiness is either in the cable or the device itself, but I won't really know that till the next device gets attached to see how routinely and effectively that gets connected and working. Anyway, I hope you've enjoyed this video. Can't say that I truly recommend this device unless it's going to be someplace that it's not going to bother you with the noise that it produces, unless you're willing to take it apart and modify it. And I have taken the can off. It's not super difficult to get to the fan. It is difficult to remove the fan and replace it, but you can get to the wires to put a power reduction in. Anyway, I hope you've enjoyed the video. Thank you.